Okay, so thanks for inviting me to speak here today. As Marcus says, I'm going to talk about water quality and how we can monitor that using invertebrates. It's actually going to be more than water quality. It's going to be about river quality, because as we'll see, it's not just about what's in the water, it's about various other factors as well. But first of all, just a little information about Buglife. We're the only organisation in Europe concerned with the conservation of all invertebrates. And our aim is to halt, so that's everything from mayflies to millipedes, stoneflies to starfish. Our aim is to halt invertebrate extinctions and to achieve sustainable populations of invertebrates. We do this through a range of activities, including inspiring others to get out there and show them invertebrates. We undertake practical conservation work like this bog restoration work near Cumbernauld. We raise awareness, we go along, we talk to people about invertebrates and their conservation and their needs, and we also try and shape policy. So we have various position statements and briefings, etc. One of which is our freshwater strategy, which has 8 broad principles that we think that society should aspire to protect freshwater invertebrates. The one that I'm particularly going to cover today is monitoring of freshwater invertebrates. So why should we consider invertebrates? Well, back in 1959, Noel Hines remarked that it was usually a chemist that was called in to investigate pollution incidents. However, biological methods were in some ways much more sensitive than those of the chemist. And the reason for that is threefold. Invertebrates tend to be quite long-lived. Most are maybe living for a year in the water. They're around for a much longer time than the chemical may be around. If you get a pollution incident that comes through and you collect a sample, you're collecting a snapshot, whereas these invertebrates are living in that water for a long time. For instance, this particular species that's on the slide just now, Dinocras cephalotes, that lives in the river for 3 years, and it's particularly relies on having good, clean water, fast flows. So if this is in your river, then it's been pretty good for 3 years. They're also relatively sedentary. They stay in the same place, so you can be sure of what's happening at that point in the river. And they have a variety of different tolerances to different factors that affect the water quality and other aspects of the river. So after Hines's paper, there was a lot of interest in developing indices for measuring water quality in rivers, and a few different ones sprung up around the country. But the first one that really took off was the Trent Biotic Index in the 1960s. This was a very basic index that looked at different families, different orders of insects that were found in the river, and scored them according to their tolerance to organic pollution. That then was taken up by other people and adapted and extended, and in Scotland the Chandler Biotic Score was developed, which looked at a far greater range of invertebrate families in that case, and also incorporated a measure of abundance. But the real game changer, I suppose, was the Biological Monitoring Working Party Score, which was developed in the late 70s and looked at almost all invertebrate families in rivers and gave them a score from 1 to 10 based on their tolerance to organic enrichment. And that was then used to classify rivers across the UK, initially across England by the NRA in their big surveys in the 1980s, 1984, around about then, and then across the rest of the UK. And it continued to be used right up to, it's still used today. Following that, there was a bit of a hiatus as people, just used the single score. But then in the 1999, Richard Chad and Chris Extence developed a similar score that actually looked at what flow conditions were in the river. And then there was a suite of different indices came out in the early 2000s. The CCI looking at the conservation value of rivers, acidification, the Army score, which I'll talk about later on, which is a simplified index for use in fisheries and with anglers, and the SPEAR method, which looked at various toxic compounds, but mostly was used for pesticides. Moving on from then, there was another set of new scores came out fairly recently now, the PSI, which looks at sedimentation. I'll come back to the Whippet score in a second. The Delhi score, which was looking at incidence of drought, and the TRPI, which looks at phosphates. And then just recently, the MIST score, which is a particular index for intermittent streams and winterbournes. The Whippet score is, I suppose, the score that covers them all. It looks at not just water quality, but actually ecological quality. It's the score that is used to classify watercourses under the Water Framework Directive, and is the score that has now replaced the BMWP score. And soon we'll also have a score looking at climate change vulnerability for watercourses based on invertebrates. How do they work? Well, here's a typical sample. We've just gone and collected from a river, and we've identified these. We've pulled them all out, and we've identified them. We then take, most of these scores have a scoring sheet or a scoring approach. This one here is the BMWP score, and you can see that the invertebrates are grouped up into different groups with a score from 1 to 10, depending on their tolerance to organic pollution. So things that are intolerant are at the top of the score, things like some of the mayflies and stoneflies, and things that are really tolerant, like midges and worms, are at the bottom, scoring 1 or 2. And what we do is we go through, we identify where the different families are on the scoring grid, and then we tot up the scores for them, and we get, in this case, we get a total score of 56. We can then also look at the number of scoring taxa. In this case, it's 9. And then also because there's various variations as we go through the year and between sites, we want to have a look at the average as well. And that's because sometimes a single high scoring taxa may skew the result. So on an unpolluted stream in the south of England, in one of the chalk streams, you might get something as high as 300 with this particular scoring system, but upland rivers could be normally quite much lower than that. What do they mean? Well, here's just some of the interpretations of these scores. So, for instance, the AWIC score, which looks at acidification, it gives you quite detailed information. It gives you ranges of pH that you can expect with the scores that you've received. The BMWP scores we've just seen there gives you a fairly broad banding. But actually, with the BMWP score and with some of the other scores, you know, it's more about the relationship between the average score and the number of taxa there, rather than just the bold figures that you see. And then sedimentation, again, some banding and some subjective conditions for the river based on that. Do they work? Well, yes, they work. This, just as an example, this is the River Spey at Falk Rivers, just down from the gauging station on the river. And here's on the left the average flow from that gauging station over since 1980, and the life score calculated from the invertebrate samples from that point as well. And you see that they match quite well. They show the same trend. And it's a point to make that the more data you have, the better. These again are from the Spey, and you can see that you can start to see trends. You can use these indices on their own on a single site and on a single point and compare between points on a river, but you know the power for them is to actually look at trends over time. And you can see here there's various trends here that we can see on this data. You see BMWP increasing and the Whippet score increasing. We can see the life score decreasing, and a knock-on effect that because there's less, that the flow is perhaps reducing, then there's a bit more sedimentation. The PSI score has decreased as well, and the AWIC score going up, suggesting that there's an increase in pH in the river as well. One thing to bear in mind when you're looking at long data sets is that the baseline is key. If we look at that, if we a schematic of that BMWP trend that we saw in the Spey, you know, and if we were to set the baseline at 1990, we would say, well, the BMWP is increased and it's getting much better. But if we were to be able to extend it back past that data set that we had there, back into the 1960s, what we might find is that it was much, much better way back in the mists of time, and we're actually still below what the river should be. And that's why we have systems like RivPACs and now RICT, which gives us a reference conditions for the river. So what we're actually aiming for with these scores and with our water quality. What I'd like to do to finish off is just to focus in on the Anglers Riverfly Monitoring Initiative and the ARMY score, which was developed by the Riverfly Partnership to provide a really quick way for anglers and other fishery interests to monitor invertebrates in the rivers. It's based on 8 target groups. These are them here. So there's a mix of orders and families. So we have 4 families of mayfly. We have stoneflies as a whole. We have freshwater shrimps, gammarus there, and we have the cased caddis and the caseless caddis split into 2. Each of these, the idea is that you do the same type of sample you would do for a normal sort of invertebrate sample. You take a 3-minute kick sample and then turn stones for a minute, and then you look at the abundance of the different groups. And the Riverfly Partnership have a calculator that then calculates the score based on that. On this graph here, the red line is actually a trigger level that's been set with, in this case, I think it was the Environment Agency, which is the level that they would be, that is above that is good, below that is there's cause for concern. And this has been used throughout the UK now by angling groups and other river interests to monitor their rivers. They tend to be monitoring on a monthly basis and throughout the year, so they're providing a much better coverage than the agencies are able to do with their limited resources. This is an example from the River Wandle down in London. The Thames is on the left, so the flows from right to left. The angling group that we're monitoring here had noticed a trend where at Site 5, which is above the sewage works, the results were all okay, and then below the sewage works they were having much lower scores. They contacted Environment Agency, they contacted Thames Water, and this sewage works was then put forward for investment to actually improve that, which was a success for them. They also picked up various pollution incidents. This one here at Site 1 was a chemical that got into the water supply. I can't remember what it was, but they picked this up really quickly, and it was able to be they were able to put in place measures. The Environment Agency put in measures to actually stop it spreading too far down the river, and you can see that Site 4 was actually virtually unimpacted there as well. Bringing it a bit closer to home, Brian Shaw, when he was in Ayrshire, did a widespread use of this system to monitor just to give a brief overview of what was happening in the catchments in Ayrshire. And this is just done as part of their electrofishing. They did the 3-minute kick sample and evaluated on the bank side. And this is the results that he got. So the big dots mean there was lots of individuals, so high abundance. The green ones are very diverse, so lots of most of the groups, whereas the redder ones are where there's less groups present. And you can see the catchment here. You can see that up in the lower area here, we're seeing red and orange dots here, which are potentially some sort of pollution incidents. And up here in the upper dune catchment, you're seeing very small dots, but mostly red. And this is probably acidification effects up in the upper catchment. If we focus in on the Girvan catchment, one of the things that Brian was able to pick up with this was a deterioration in water quality downstream of a point on the main stem. So up in these tributaries, everything looks fine. Up in the top end of the catchment, things were okay, but downstream of this point, there was very little life in the river. And what this turned out to be was an incident with a sheep dip I think it was, that had got into the stream and it killed off the river all the way down, virtually all the way down to the sea. So that's really just a very quick introduction to what you can do with invertebrate data. I think the key thing is that you can collect a sample of invertebrates, and you collect it once and you can interpret it for a whole range of different topics, to different factors. I'm happy to take any questions, or please get in touch with me by email if you want to have any more information. Thanks.